recording. Okay, so today we're gonna, well, just for the context of the recording, we merged a thing, right? So we merged uh, LFA migration branch, which means that our runtime now uses LFA instead of Erlang. Uh, it uses LFA instead of Erlang, which means that uh, I can delete those things. Uh,
I'm pretty sure we should. I'm pretty sure we actually do need the header file, but we could probably translate that to LFE as well. It's just a
we don't need
type
the header
definition.
file because it's this. It's
Hmm.
literally this. But there is no differentiation of header files in LFA.
Uh, we do need to include it though. Are we doing that? I think we are, right?
Yeah, we are including it, but you're not using it anywhere. And I don't have my
But
LFA mode working, so that's why it's doesn't have colors, but it's in here.
yeah, that's not the right file though.
Yeah, it should be this. Well, we're not using this anyway, so that's why it didn't complain. But I can actually let's actually commit that. Um, yeah, we forgot to delete those things. Sure. Yeah, let's commit those things. So um, clean up files after LFA migration. Cool. The reason we did it this way is because with this we can now rely on the serialization done by the Lisp stuff instead of serializing deserializing yourselves like we started doing 2 sessions ago or whatever, where I was creating S expressions out of tuples. The only trade-off is that now we cannot use tuples anymore. We need to use lists instead, and we have to remember this when generating the OCaml portion, which is very understandable. But that's not what we're going to be doing today, and I have to fix my LFA mode. I haven't added to my config, so that's why it's still broken. What we're going to be doing today is this is wrong. This is wrong, which leads me to believe that I didn't pull, but I'm very sure I did. Sakura integration. You couldn't find it. Ah! Ooh, I think I did some bullshit. So let's fix the bullshit.
Uh,
Because it's Sakura integration query, isn't it? Yeah, it is. And now we need to pull from master. Yep, there we go. And now, yeah, then we still have the same problems as before. Yeah, we still have the same problems as before, but let me just check if I'm not deleting. Yeah, no, we forgot to delete those things anyway. So let's actually do that and do that. And now,
don't forget to change the include.
yeah, I also need to change the include. Actually, this is also wrong.
That's yeah, should be types.
Uh, okay, now it is correct. Okay, now going back to the point. What we're gonna do today is to start supporting these sort of files, right? So we allowed the compiler to accept via the CLI multiple files, which is great. And we are actually allowing these extensions of files to be passed to the compiler. Karuta files, Sakura files, and Prolog, just because our parser accepts things written in parentheses. What we need to do today is to actually go through the executor and figure it out what we need to do until we reach the compile, yeah, this step function. And then in there, probably you're going to do things about it. So there's initialize function, visit tags, blah blah blah. I think I have to restart my Emacs, unfortunately. Actually, let me pause the recording because it's don't pause the recording. Okay, so here we are again with ideally my shit is working, and what we need to discover is what the heck this does. Yeah. Uh, okay, so inside of the compiler we do have the file name. We do have the file name, which means that if you go to compile, inside here of the compiler we have the file name, right? So my understanding is that we could do something like inspect the file name inside of the compiler. If it is Karuta, we continue doing whatever we're doing. But if it is Sakura, we need to do something else.
Hmm.
Because the rules are not quite the same.
Yeah.
The rules are quite not the same. Because in my understanding, we cannot have queries inside of a Sakura file. Can we?
Not really. The idea with a Sakura file is that whatever you define there will be stored in the database, like as a schema. And you don't normally store queries in your database, do you?
Yeah, no. That's kind of well. If you ask the SQL people, the answer is going to be yes. You can store anything in a database. But storing a query, I think it's more like an application type of responsibility. That's a stored procedure. No, that isn't, because a stored procedure is a Sakura directive. It isn't a query. So that's the plot twist. A query is particularly so far the semantics of a query is particularly from an application to the database. Not it cannot be like a stored procedure is something else. Which, by the way, that is the thing that I have no idea how we're going to pull off, Marinho. Because remember, we need to store functions, but we have relations. How the shit we're going to store that? So that's why I wanted this to be done at the end of the thing. But anyway, so let's start. So what are we going to do? We're going to do something like s compiler, and then in here we're going to do something like a file name underscore. Is that how we call this? Yes. Then we have to check for the extension, right? Then we have to. Actually, we don't because we have a Sakura flag in here, isn't it?
Uh, we
Yeah, we do have a
do.
Sakura flag. So if Sakura, then we're gonna do probably Sakura step, and then we're gonna pass exactly the same thing. Compile clause, blah blah blah.
Didn't we add
Actually,
that flag when we were originally going to like think about embedding Sakura directly in Karuta? Like the
with the
like
extra
being able to
syntax,
yeah, being able to nest the languages, right?
I don't
We're
think
not doing
I don't
that
think that's the
anymore.
case. Yeah, but I don't think that's the case because we did this. We already made the Boolean thinker of a different file, as you can see.
Hmm. Okay.
Yeah,
Yeah, I forgot we did that.
yeah. This is for us to not have to do this all the time. We do it only once. Um, okay, so now we're gonna do Sakura compile clause compiler. Else we do that. What do you say?
Uh It feels like we're checking the flag too often, but I don't think we should worry about that right now.
Well, but this should be checked per module, isn't it?
Not really, because if you are inside of a Sakura file, you know everything is Sakura. So you could just check it once, but
Hmm. So what are you recommending? Are you recommending to us doing executor then? So like in, I guess, step here, we do the check here, and then if we are in a non-Sakura file, we just call this. But if we are in a Sakura file, we do something else.
yeah, that would be the natural way to do it.
Okay. So if that's the case, let us just grab the Sakura under information here. Do it like that. Ma Do I have to do compiler types this? Or is this how you're not supposed to do that? Syntax error, expecting equals unbound record field Sakura. And then we just remove all of this that I just did. Um, there we go. It's the same as before. But in here, hmm. So what would you recommend? Would you recommend this?
Hmm, yeah, that seems like the way to go.
Okay, so let's make a function. Um, let's
Ah, sorry.
create.
Hello,
Can you hear
Magenta.
me?
Hello.
Yep,
Is it noisy, my mic, or is it fine?
It is fine.
Okay.
very
Uh,
fine.
I will answer your questions, Devo, in just a moment. Let me read them. Mm,
Well, actually, this should mirror this structure. So I'm also gonna do that. Um, so we have that. We also need to persist stuff, and we also have this type of stuff. We also have that. I just returned the compiler here. And let's see how bad this compiles. There we go. So let compile prime. Blah blah blah. Syntax error. Yeah, so I did something wrong in here. That's not how you do that, but I forgot how you do that. Ah, is it because of this? Yeah. Off the freaking course. Unused variable. Like that. Okay, that works. Next step, copying this.
Do we actually need to copy all that?
Yes, because we're gonna copy to then remove. Okay, so the first thing we gotta do, is to understand which things we're gonna keep and which things we're gonna delete. My understanding is that the query is gonna go away. What's your understanding?
Y- Yeah, we probably shouldn't allow query to be defined in a Sakura module because that doesn't make any sense. We're going to
Behavior, clause, lock, blah blah, exit one.
Because like a query is basically an entry point, but it doesn't make any sense to put an entry point inside of a database schema.
Yeah. So Sakura's schemas do not allow queries. Actually, there is a point of conversation about doing this. We could remove the queries in the preprocessor if it's a Sakura file. What do you think? But I think it can be misleading because we're not going to explode by saying, like, telling the user, hey, you cannot do this. And in the preprocessor approach, we're going to just remove it for you. We're going to just ignore it. The reason to do that, the only pro, is that if you have a Sakura file, you can easily change it to a Karuta file, and the query is going to be understood differently by just renaming the extension. So what do you
That
say?
sounds like a foot gun, potentially.
Okay. So let's keep it like this for now. We can always change this later anyway. Okay, so now, what about the rest of the stuff? So we have a directive that is not that is qualified. This is also true in the case of Sakura, right? We're not going to qualify directives in here.
We have no need to. Yeah, we won't qualify directives.
Okay. Then we have directives that are like normal directives, which we're going to have to take care of it, and then we have multi-declarations, which we're also going to have to take care of it. All of those two things you're going to care in Sakura, right?
Yeah.
Okay, I think we're going to have to make a folder because we're going to have to do the same kind of things that we did for the compiler. So first a directive inside there, then a declaration, yeah, declaration, and I think we're going to be able to borrow the signature stuff and the lookup stuff from the compiler. So I'm not going to create them. But we need at least those two. So in here, we're going to say Sakura. And in here, we're also going to say Sakura. And let's copy more stuff. The dream of most programmers, copy pasting. Copying all of that.
I'll send them in order. Okay, Tevo. So the first one, let me know if you understand that while I respond to something else here.
Which imports do I need? I need types. So let's copy that, and this is compiler types. Okay, so Maninho, there is a couple of things that I want to talk to you about. So my understanding is that most of these directives you should be able to delegate to the compiler. Am I wrong?
Some of them you will, not all of them though.
For example, let's start with the first one. Module 1 with a single body. So a module with no signature, right? This is what this is. What should we do about this one? Should we delegate or should we do something special about it?
The problem with delegation is that if you just call the function from the Karuta compiler directly, you're basically going to switch the meaning of the body of the module from a Sakura module to a Karuta module, and that's not what we want.
Well, I agree that's not what we want, but I also want to leverage the reusable parts, right? That's kind of a big deal because we already have a lot of infrastructure to make a lot of things happen, such as lookups.
We may be able to reuse some of it if we parameterize a few things. In particular, we need to parameterize what we call recursively inside of the module. Because like at some point the module case there is going to call compile recursively, right?
At some point there, it's gonna call compile recursively. Yes, it will call the step recursively. That's true. That is in fact true. Uh,
Wait, are we already taking the step as an argument?
yeah.
Hmm.
This is the copy-pasted version of what we do with the Karuta stuff, so it's identical. And in the Karuta one, we get this.
Hmm.
So let me
Interesting.
think a little bit. Let me think a
So
little bit.
actually, we probably can reuse most of this.
No, but there is a problem because the lookup process assumes like normal scoping behavior. But I think that these portions are the portions that we have to care about the whole global stuff.
Yeah, those. Yeah, the scoping rules are different. That is true.
The scoping rules are very different. Well, I think everything is going to suffer from that actually. Because everything is using lookup. Which kind of means you cannot literally reuse it.
Should we functorize the compiler and take the lookup rules as a parameter?
That sounds a little bit overkill. I rather try bottom-up approach, which in this case is to make the lookup functions smarter by having extra parameters. Could we make the lookup like like double duty by passing a particular argument?
I mean, we could, but do we want to?
Well, like I said, I think making a functor for this is a little well. Making a functor necessarily is not overkill because we can make a functor out of the lookup, for example. I think making a functor of the compiler is a little bit too overkill, but making a functor out of the lookup is
No,
fine.
no, you can't make a functor of the lookup because, well, actually, can you?
No, the lookup is a module. Why can't you?
What's the parameter for the lookup?
Whatever is necessary to differentiate global stuff than normal scoping rules.
Okay, then how do you inject the lookup into the compiler? You see, that's why the compiler needs to be a functor, because the lookup rules are the parameter.
The lookup rules are the parameter. It's because our compiler is not really, it's only a type, you see. It's not a module. There's only the type T that is holding the state of the compiler.
Well, it would be probably the compile function and all the friends, like step and such, would be inside of the module.
So you want to make the compile a functor. That is actually a good idea, now that I think about it, because we are repeating ourselves with compile clause and step already. So those would be part of the interface of the functor, wouldn't it?
Probably, yeah.
Okay, I think I like it. I think that's enough argument to make a functor out of this now. So let us see. So to make one of those, we need to start by having a signature. I forgot how I managed to make that happen here. So let's do that. Yeah, so that's how you do it. This is the contract.
Yeah, we actually should make two signatures.
What is the duty of each one?
One is for the argument of the compiler functor, and the other is for the return value, which is the compiler interface itself.
I don't think I get the second one.
Because then we can say, okay, we have separate instances of the compiler for like one is for Karuta and the other is for Sakura, right? But they have the same interface. They have the same signature.
No, yes, but my understanding is that this would be like, I don't know. I don't have a good name. So let's say argument. Let's actually call it config. And inside of the config of a compiler, you need to provide a couple of things, including the lookup functions and the step function and the compile clause function. Actually, you only need the compile clause, isn't it? Because the step is always the same regardless.
The step is always the same. Yeah.
Okay, so this, let's go to the functor again. Uh, that's actually that is what I
Yeah.
want.
Yeah, the step would be part of the signature of the compiler of the results module.
Yes. So we have, I don't know, a compiler which receives a particular config. Is that how I named it? Yes, that is how I named it. And probably I need to do that. So the step function, actually this is going to be a little bit interesting because the step function and the compile clause function are recursive. So how you're going to make that happen, I have no idea.
The compile clause would need to take the step as an argument.
Yeah. So here we're going to do config dot something along those lines, right? And this is always going to be provided to all the a step function is always the same for all of our compilers. Is that right?
Uh, yeah, it should be. It
Okay.
should be.
So the other thing we need is the lookup functionality, right? So let's actually grab this and put it in here. So this is our requirements. Boom, boom. And then you're gonna be a function that receives one of those and one of those. Oops. And you return one of those. What else?
Um, does the lookup module have a signature?
Yes.
Well, it should receive. Then one of the parameters of the config should be a lookup. Then.
Mm. Well, but there's a problem there, my friend. We have a bunch of lookups. We are exporting all of those things out of the lookup.
Well, the parameter is a lookup.
Let me see if I understood what you're saying. You're saying a lookup module. You need to receive a module.
You need to receive a module. This is a functor. You should always receive a module.
How do I write that like this? Is that how I do it?
Um, yes, and you need to give it an explicit signature.
Which in this case is going to be what? Lookup,
Not like that. You need to do a colon, I'm pretty sure.
but compiler lookup? How do I do that?
Uh,
I
we
think we
have
did
the
this with
lookup
EST.
signature. Yeah, we have the lookup signature in the MLI, right? But um, we don't have the signature itself as something with a name, do we?
No.
Because that's what we need here.
Magetta, do you know how to make this happen? Magetta.
Hello, not Ace.
I think Magetta left for a bit. That sounds annoying, Marin. That sounds really freaking annoying.
Hello, everybody.
Hello. So let's search how to reference. There we go. Let's see if the search engine does the thing. Oh.
There we go.
I don't wait. Ah. How do I do that? How do I do that? So the AI is saying to use include money.
It's wrong. Don't trust it.
No,
Include.
but do you know how to make that happen, Magita?
I don't even know what the code is, man. Let me
Okay,
see.
can you? Okay, my screen is sharing right now. Here's the
Magetta,
situation.
the short version is this. We are turning the compiler into a functor.
Okay.
We need the lookup rules as a parameter of the functor.
Okay.
We have a lookup module and it has a signature, but the signature is inside of an MLI file. It's not actually a named signature.
Right.
Is our only
So
option to turn that into an actual named signature?
the thing is that when you say the scope of the signature is hidden inside of the MLI, is that it?
Yeah, like we have a lookup module. It is a file. It's not just an expression in a somewhere else, right? Which
Oh,
means
I
the
see.
signature
I
is an
see. So there is
MLI.
the thing on the side. Oh, I see.
Yeah.
Uh, you do have a signature there, but on line 9. That's not it then, is it? That's another signature that
No,
you
no, no.
guys have.
This is the signature we need to
Oh
reference,
no,
but
that's
this doesn't
your
have.
code. I
Yeah.
see. No, this is the Karuta signature. I see. Uh, yeah, I thought it was strange. So I'm not sure if that will turn the signature into an opaque object, though.
Yeah, because like the situation is you see on the left where we have a module lookup which is inside of a signature, right?
Yeah, I see. You're trying to import the type, right, of the MLI, but you can't find it. Did you try on Doom, like building? What did it say?
No. Okay, let me try that. I haven't tried that. So Doom says there it is. The following
Yep.
module and module group cannot coexist in the same executable. Ah, of course. Oh, but
So
this is
that's
gonna
another
die.
error.
No, 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 that's a different problem. That's a different problem. Let me fix it real quick, styles here.
Uh,
This. Let me think. So we have that. Okay, now it should complain about something else. Yeah, there we go. Okay, so it's complaining unbound module type compiler.lookup. There is a module named compiler.lookup, but modules are not module types. Yeah, this is a module as well, but we have an MLI file with this name,
see,
and that is a signature that I need to reference.
I know something cursed you can do, but not sure if it's worth it. You can make like module type and then like whatever module equals to module type of whatever. You see, like you can make that, but that's just cursed. Uh,
If this was Zig, I would just say use a type of and you're done. But we don't have type of in OCaml, do we?
Okay, your Magetta is saying to do this, right? So lookup s, and then we just say include compiler lookup. Oh, but there must be a type there as
oh,
well.
OCaml doesn't let you directly refer to the MLI file as a first class object.
You're reading that somewhere or you're asking?
That's Google Gemini.
Okay, so you cannot do it.
You trust Gemini?
Given the
Oh, you can include. Oh,
yeah, yeah, but
wait.
how
You
do
can
I do
do
that?
this. Okay, let's see. So try module type, and then you may. But then at that point, like, okay, try. Let's try. So module type, and then ABC, whatever, and then it's a signature, and then you include the module type of blah blah blah. See if that works.
Include
Module type.
compiler lookup And
No. Yeah, include module type of, yeah, of this guy. And then lookup s down there. Okay, that works. But then can you put like module type of blah 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 on the comma? I don't think so, but not the include, but
yeah, but I want to try this first. What if I put
You would have
no, it
to,
parentheses?
doesn't. Yeah. No,
yeah,
remove the yeah, the
remove the
include.
include.
Oh,
Okay, that's it then.
Ah, so we do have a type of, I
So
guess.
you actually can. Google Gemini lied then. I mean, you cannot. That well, actually didn't, right? You can't really reference as a first class object, but you can reference from the type of the module that instantiates out of that.
okay. I have a question, Marinho. Now that we got this figured out, are we gonna rewrite lookup for Sakura to fulfill these exports?
Well, yes, because we need another module that does the lookup using Sakura's scoping rules, which are different,
No,
right?
but they are more different than similar. I thought they were more similar than different.
Well, the interface is the contract. We may want to adjust the interface, like the actual signature, maybe. Like it's not clear at this point if this interface is actually the correct one for this use case.
My intuition is telling me that this is a little bit too much because most of the code is going to be copy pasting, and only in a few places we're going to have different behavior. And that I think this is like there's going to be like loads of copy pasting by replicating this. But okay.
I mean, in the worst case, I was gonna say we could include, like, we could make a module for the common parts and include it in both, but there's a slight problem that if you include, actually no, include is not open. Yeah, no, include is fine actually.
There's another problem.
And I'm loving that Tevo is asking me questions.
Awesome. There's another problem, Marin. Lookup is not used. It cannot be used in here because this code doesn't use it. This code calls compile clause, and compile clause calls directive, and directive is the one that uses it. And I'm not even sure if that's true because maybe we're also using in here. Yeah, we are also using lookups for signatures as well. So we need a way to use that lookup that you're providing us externally into these inner layers of the process.
Just pass it down as a parameter.
Pass it down as a parameter. So do you mean having the lookup module as an argument for compile clause and like pushing that dependency down?
Yeah.
That sounds a little noisy, but actually, can't we put the lookup function module inside of the compiler type?
Can't we? I mean, we could, I guess.
Because here's the
But
thing.
then would
Go on.
but then we would have to rewrite the existing compiler to use the reference from the compiler instead of calling lookup
Yeah,
directly.
that's completely understandable. But I think that's less because here's the thing. I think the lookup has a very intimate relationship with the compiler, so I don't feel bad by adding that to the compiler itself. What do you say?
Hmm, does it?
Where is the type? Here. We already have persist. Why not have lookup?
I suppose that's an option.
Okay, so lookup, and this is actually gonna be a module, which means I need a module type of lookup. Is that how you do that?
That doesn't quite work because module level types are not the same as value level types. You need to do there's a way to convert between them, but I don't know off the top of my head what that is. We'll have to look up. Let
Yep.
me
Let's
open the
search.
docs. Uh,
We are making the compiler a functor. What a day to be alive.
let's see. Let's see. Invalid package type, only module type identifier.
I mean, it makes sense. Like, we're not trying to just be fancy. We actually have a justification to make the compiler a functor.
Can't we make it a proper functor? That would probably be easier than trying to fiddle around with the weird syntax that OCaml has for first class modules.
It's gonna be a good day. If you had went with tagless final style, it would probably have been a functor from the start. That sounds overkill, Tevo, because there was no reason so far to do that. No reason. We just now noticed that we have a reason. Did you figure out, Marinho? What's the syntax?
Uh, Passing modules to functions, runtime selection. Mm, how do I?
How did I do that here?
There's the module type, module.
You too. Please have a good Friday. Happy Friday.
Happy Friday.
Happy Good Friday, actually. That's what he said.
Be good
Oh yeah,
Friday.
it's Good Friday. That's the English name.
Mm,
That should invalid package type.
Oh, there's a problem. We won't be able to initialize the compiler anymore without knowing what the file is. That's interesting.
Don't we need that regardless?
Well, but right now we're not doing that. But we will
Like
have to.
the file name is a parameter, no?
Yeah, no, but the initialize. Yeah, actually, you are right. We would have to do that anyway. But we need to figure out how to put the lookup module signature in here.
Hmm.
And this is not how you do that. Well, this is how you do it, apparently. Okay, so thank you. Thank you, AI, again.
Huh.
Um, okay, so now we have to put lookup equals something. We have to put
Well, if
lookup
you're
equals
doing a
something.
nested initialization, the lookup rules for the child should be the same as the ones from the parent.
You are completely right. So this should be an argument. Because then we can just call here. But here's the main problem, in my opinion. Here's the main problem. Um, a compiler is a functor. So initializing a compiler should be instantiating the functor, isn't it?
Well, the compiler is not a proper functor, but yes, it should be.
Wait, it's not a proper functor? What do you mean?
Because it's a record that happens to have a module as a field.
No, but I'm talking about this functor. This is gonna be the compiler, and the compiler is using the type anyway. You see?
Well, then that means initialize should probably be part of that.
That what?
Of should be a part of this struct as well.
Oh, okay,
Actually,
that makes sense to me. Actually, this entire thing should not live in here.
I'll be right back.
There we go. So we have that, and initialize should live here. Which probably means that nested should also live there, because nested is very intimate has an intimate relationship with the other thing. So we can do that. Yeah, that is true. And then this thing, so it should.
Sorry if I misread you. I think you understood, right? The idea of the garbage collection, I think. It was just to eliminate the session because there's no concept of really connection. That's basically why. So long as you have the hash, you can connect from somewhere else. So there's
I
no
don't.
way to tell when to disconnect. That's the
Are you
idea.
talking to me or to Tevu, Magit?
Tevo.
Okay, just be careful because you said not having the session. We need the session.
No, we do. I'm just saying that we don't have the concept of a connection. Like it's literally just a socket that you go
Yeah,
there and
yeah.
send stuff and retrieve, right? So
Yeah, we're
there's
probably
no.
gonna actually do have a timeout functionality so you can know when to disconnect, but that's
So he
not
was
now.
asking about the garbage collection, right? And it's very flaky and bad,
I thought it was
but
absent. I'm pretty surprised.
it's very dummy. If I show you the code, you will laugh. It's just a timer. So and that's just for like if to avoid zombies, right? You just open a cursor, never finish consuming it, and then like lose the connection.
Okay, does this compile by any chance? Oh, module types in directory depends on compiler. So who depends on compiler? Oh, this guy. Now there is a cycle. Ah, fuck me. Yeah, this is a problem actually. Yeah, this is a problem. Uh, mm, mm-hmm. We have a problem. But how are we gonna make that? That's funny. Didn't know that. Okay, I'm gonna wait for Marin to decide what to do because there is a cyclic dependency here, and probably the solution is gonna make to make a separate file, but I don't know what to name the file.
Lemos, just one question. Is there the
Yes.
possibility you guys may want to disconnect and because you will consume once at a time, right?
Yeah. No,
So
for now.
assuming you kill the code, you will lose the connection and then you will lose the state of the whole program. So it doesn't really make sense to store sessions, right, for you. like cross program RAM run.
Yeah, no, it doesn't. It doesn't at all.
Is there a case for the database to do that though? Because that answers the question you
Well,
asked
I
Tevo.
think there should be a timeout functionality. Like if we haven't poked you in, I don't know.
Like Tevo is thinking of tying that, if I understood, to the connection, which makes sense because if the connection dies, it just kills all the things with it. It's like an init, right? Uh, I'm just thinking if there's any case of where we want to leave something enduring a connection, but I can't really think
I
of
don't
one.
think so. I really don't. If
Well,
the
there is the
timeout,
case of stored procedures,
well,
but
no, don't think of them right now. The stored procedure is going to be the last thing we will ever do in this thing.
I mean, background jobs, right? That's what I meant, really. Like launching threads on the database, that should be possible too.
Well, but
I'm
then,
back.
oh, okay, Marinho, we have a problem then. We have a
Uh,
problem.
okay.
So I moved the functor to the where the compiler type is, and that broke things because the lookup is referencing this file, and now this file is referencing the lookup. We can either move this back to the compile here, but then the initialization functions will be like locked with us, or
Shouldn't you just bite the bullet and make a proper signature, not an MLI file, but an actual signature, because we're gonna use it in multiple places?
that doesn't fix the problem.
It does, because we actually only depend on the signature.
That doesn't fix the problem because the problem is where this functor is going to be located. If we make a signature or not separately instead of the MLI file, we're going to still reference types, the types file, and that is the problem.
Back.
Like the types file, like lookup is
No,
referencing the
you can
types
make.
file. Go on.
No, no, no. I mean, you can make, like, you can move the signature of lookup to the types file. No, that breaks the cycle.
Uh, that sounds bad, but it is an option because now we are making this bucket be out of things that are not related to the compiler, which has been so
Didn't you
far.
just say a few minutes ago that the lookup and the compiler are intimately related?
Well, they are intimate related, but not to that level I was assuming, but now we are kind of making it to be very deep, the level. So you want me to grab this thing and put
Like,
it in a
the fundamental
fragment?
problem is that you cannot refer directly to the signature of lookup, so you're referring to it indirectly by using the lookup module, right? And that creates a dependency cycle.
Well, we
That's the
can,
cycle you want to break.
well, yeah, exactly, but we have other options to break the cycle. We can make the functor outside of this file, and then the trade-off is that the initialization functions comes with us. And then we can create a separate file, we can go back to the compile, like we have options still. What you're saying is another option, which is to just put the lookup signature in here, which is an option. Which option is the best one?
Mm, I think we're gonna have to move the signature for the lookup module anyways, because we want to reuse it for the Sakura lookup, no?
You think we're gonna have to move the lookup signature to a separate thing anyway because of what?
Because we're going to want to reuse it for the Sakura lookup, right?
Well, but then we're just gonna do this.
But then the Sakura lookup will start depending on the Karuta lookup.
No, not the Karuta lookup, the Karuta signature.
No, it will depend on the Karuta lookup because we need the Karuta lookup to look up the lookup signature.
I am confused. I'm talking about which signature you're gonna be referencing.
The
That's what I'm
problem is
talking
that
about.
you're referencing the signature through the module. I'm suggesting we should reference the signature directly.
Wait, this is referencing the signature through the module?
You're using a type of, Lemus.
Okay, but okay, so this is actually grabbing the signature out of the ML instead of the MLI.
Um, well, yes, you're basically saying, you
Okay,
know
so
that ML file, give me the signature of that.
okay, but then this is bullshit. I thought this was a bad way of getting the MLI reference. This isn't. Okay, so I
No,
need to
no,
show
you
you
are getting
something.
the MLI reference, but you are doing it indirectly because you're using the lookup as the thing that you actually can name, you see?
That's not what I wanted to do.
Man,
So
I'm
what?
so glad you guys showed Tevo to me because I don't need to explain things. He just gets it.
Yeah, but well, we told you before. Tevo is a prototype of a marinho.
Yeah. So everyone has a Marinho. That's the good ending.
Well, but there is
Do
a
you know
problem.
the
Tevo, we are Tevo's second child. He already has a second study group. Well, a
do you know
former
the
study group.
do you know the I think it's from Shin Megami Tensei, the bad ending. The whole world is Brazil. Do you know what I mean? So there's the alternative is the good ending. Everyone is Tevo. Everyone is Marinho.
Uh, okay, so I did what Marinho said. What is the problem now? Unbound module lookup. There is a module named lookup, but modules are not module types. Wait. Where? Man, what the fuck happened here? Like, this is a new thing after the upgrade of the flake. What the fuck happened there? But okay. So unbound module type lookup. Where is this happening exactly? Are you not gonna tell me? You're not gonna tell me. Okay. So what do I do? What do I do? Marinho, do you have any idea what's the problem here?
Um, okay, you have a config,
Yeah,
which
look
is a
at the error
signature.
message, how terrible it is. So somewhere we're
Unbound module.
referencing the lookup via like as a module. Maybe this is a name. This is a problem with this name. Maybe. What do you say? Because this name is conflicting with this name. What do you say?
Where did you put the signature that you were
Immediately
using
above.
there?
Ah, wait. This is referencing types. Okay, yeah, but this is incorrect. Yeah. Yeah, and this is also referencing types, so we should not have that. Because now they live in the same scope. Okay, I don't think that changes anything. Yeah, that's still wrong. So maybe it is referencing this portion here. See? So is that the problem? Maybe?
I don't think that's how you do it, Lemus.
Oh, that's not how you do it.
Like you're doing config, which is a signature, and you're trying to look up a module inside of a signature.
Ah, wait, I think I know the problem. This should be up there, and I need to reference it in here. Don't I?
You do, yes.
Like this. Ancestors. And blah blah blah. Oh wait, this type is recursive with this. Okay, can I... Is that a thing? Can I do that? No, I
Nope.
can't. Okay, so there's a problem. This type and this module signature are mutually recursive. So what do you say?
I mean, if you put t inside of the inside of the functor down there that already takes the lookup as a parameter inside of config, that should fix the problem, no?
Wait, what? No, no, no. I'm saying that this type has a module signature as an argument. Like we're defining this type, this record type, and one of the fields has a type of a module, which is above. But this signature references the type T.
Hmm. It references the type t.
We can't define it in the module.
No, this should live outside of the signature.
Can't you make... but that forces you to tie a recursive loop. That's not great. Hmm. Hmm. Yeah, that's actually kind of annoying.
Oh yeah, but is this even solvable? I mean,
Let's see. Lookup depends on t, and we want to make t depend on lookup.
yeah, essentially.
Hmm.
Oh, you might have to wrap T in its own module and
Yeah,
then
I
do
was about to
module
say we
rec.
could make T inside of a module and make that as a lookup S receives as an argument, like make this another functor. Like, man, this is getting a little bit out of hand. This is getting a tiny bit out of hand. What happens if I do this?
You can actually... No, there's actually a better way to do it, Lemons. You can do...
Oops.
Yeah, no, get rid of the types dot, put a type t at the beginning of that lookup s, and then... yeah, and then... and then... But then we can't use it directly, can we?
I
Is that
think
a
we need.
problem?
Well, I think we need to do what Ace said, but continue.
Because you can do a with when you use the signature to say, okay, this t in the signature is actually the same type that exists somewhere else.
You mean down here, like this?
Yeah, but then you need to make t recursive, right?
Make T recursive, like this? That's not how that works, right? This is already recursive because we are using it in here.
Ah, yeah. Types are recursive by default for
Yeah,
some
but this
reason.
is wrong. Invalid package type. Only with type T equals constraint is supported, the type blah blah blah. Let's actually see what the compiler tells me. Syntax error. This is not how you do it. So, module signature with syntax OCaml. So, how do we make that happen?
Yeah, I think t just has to be a functor.
Well, then Ace is right, but then Ace is right. Unbound module config. Okay, this worked apparently, but now, oh, it's because this is wrong. This is not how you do that. This is compiler. Oh, but then this is going to be confusing because we are inside of the compiler. I should rename this.
It should be uppercase. Yeah.
And then this is how you do that. And then here, we just do
Config. Dot lookup.
config. But is it this lookup though? That's kind of the question.
No, it needs to be lowercase, and then you need to do. There's a special syntax to turn a module value into a proper module. Or rather, this is
This
config.lookup. That's
doesn't make
actually.
wait. This doesn't make sense why it's lowercase to me. Because in the config, we are saying that our config has this lookup. Why are we
Oh yeah, no, it
referencing
needs to.
it?
Oh yeah, no, it needs to be uppercase, but then you need to turn it into. Like you need to do module config.lookup basically.
Module like this.
I think that's syntax, isn't it? Let me see. Int comparable, blah blah blah, module. Um,
This expression has this type, but an expression was expected of this type. Wait a moment.
So you probably need to change that above on line 99.
Above. You mean here?
Yeah.
Why?
oh yeah, you actually need to do. You have to do inside of 104. You can't just use lookup s. You have to use module lookup s with type. Same thing you did on 99. Yeah.
Wow. Man,
Magic.
I think they broke OCaml. What the fuck? They broke it. Okay, so unbound value initialize nested. What do you mean? It's in here. I'm so confused right now. What is the zeros telling me? Line 11, wait. Oh, it's inside the reactive. Um, it's because this is using initialize nested, which is now not available because it's part of the functor. Well, but this is understandable, right? Because we are making a functor of the compiler, so this is going to be broken for a while. Okay, what else do we need? What else do we actually need, Maria? What else do we need?
Mm,
But here's the thing. Whenever we finish this functor, what we're going to be passing through everybody is not going to be the type T anymore. It's going to be this module, isn't it?
which means.
Which means the type T should be part of the functor, doesn't it? Or am I tripping?
Should it?
No, because here's the plot. Everybody's taking T right now, but now we want them to take the outcome of this functor because some of them will use lookups. They need to use our
No.
lookup, the lookup that was provided via the config.
Well, yes, you need to do. You need to call make with the configuration that has the lookup inside of it, and then the resulting module will have an initialize that can give us a t.
Okay, so what you're saying is that we can still keep it up, the everybody receiving T instead of receiving a module. Is that what you're saying?
We should be able to, yes.
Okay, but here's the question. Should we do that? Should we have these two layers of abstraction? Of having the type be disconnected out of the functor? I never
Mm,
did this before, so I don't really know what to expect.
My intuition tells me that we're slicing up the modules in the wrong way.
Which modules are being sliced in the wrong way?
Okay, we have make, which returns a structure that has a step and it has the initialize function, right?
Yeah, exactly. We should actually make that. So let's actually make the other signature you were mentioning. So this is gonna be what? This is a compiler, and we're gonna return a step. What are we gonna give you? We're gonna give you this. We're gonna give you that. We're gonna give you an initialize functions. So val. The problem is that I'm gonna have to type this bullshit. Yeah.
I don't think we should give initialize nested though.
We must. Directive module requires it.
Why?
Uh, because because of the nesting of modules inside modules.
That feels like it's an abstraction leakage, which tells us we're using the wrong. Uh, we're splitting up the modules in the wrong way, basically.
Oh, but this function was already there. We're not splitting them wrong. We're just moving things. The initialize nested was already created before.
No. I'm not talking about what already exists. I'm talking about the new module structure that we're writing right now. I think this is not the proper way to factor it.
Okay, so how would you make that happen?
I'm not sure. I'm still thinking about it.
String and t. And we're also going to give you an initialize function, which receives a persist t, a string, and returns a t. So a persist t, a string, and it gives you a t. And that's it. We're not going to give you anything else. So now we just say that this gives you a compiler. Why is your intuition telling you that we should not give access to the nested version? Marinho.
Hmm.
Isn't that kind of an implementation detail of initialize?
Well, it kind of is, but at the same time, it kind of isn't. Because here's the problem: is these um, this thing. Yeah, I think this is a problem now as well. Now that I think about it, what's the plan? The plan is that we identify. Actually, let's type that down. Um, let me explain so then everybody can be on the same page. So the first step number one, identify which file we are about to compile. And in our case, it matters this or that. If it is, well, on which one, create the appropriate module out of the compiler functor. Initialize the compiler using initialize function in the output module of the functor. And then when compiling directives, we use initialize nested, which we don't have available in the type T. And I think that's
Okay.
why Marinho's intuition is saying that we should not allow it, because we want to depend everybody to depend on T after, like, we only depend on the module and on the functor in the beginning. After we call initialize, and T should be everything we need. But that's not the case because directives must use, well, not must use, but they are using initialize nested.
Okay, here's the thing, Lemus. How to compile a directive is a concern of the compiler, right? It's not a concern of the caller of the compiler, right?
Yes.
That means that initialize nested should be private to the compiler because the caller only cares about how to initialize the compiler, like from the start, and how to actually run the compiler, right, with the step function or whatever.
Yes.
It shouldn't have to care about the fact that the compilation process is recursive.
Also, yes.
So initialize nested, yes, we need it internally, but it shouldn't be part of the interface of the compiler.
Yeah, but how are we going to communicate to the directive, the compilation of directives about, we need to somehow do that. I agree with you, just to be clear. I agree this should be not here. I agree. But at the same time, we know that directives which are being called by compile clause, they must have access to an idea of nested things.
Okay, quick question. Does Sakura and Karuta have the same directives in general?
Yes.
No, actually.
Yes.
Directives. What do you
Yes.
mean
Yes,
directives?
because a Sakura file can also accept module and signature directives.
Can
But a
also
Sakura
accept.
file, like a Sakura module is not the same as a Karuta module, or a signature for that matter.
Wait, are you saying that we should have an argument to compile directives?
Maybe we should.
Because here's the difference. Right now, Karuta supports these two. Actually, that's a lie. It also supports comment. And Sakura is going to support everything Karuta does. Everything Karuta. Plus a bunch more stuff.
But you see, the Sakura module and the Karuta module are not actually the same. They have the same name and they fulfill the same role, but the body has different semantics.
I agree. I agree. I agree. So they deserve to be here, but they have asterisks. So like that. Actually, this is probably the same.
Yeah, comment is actually the same.
Okay, so what are you proposing with that? Are you proposing for us to pass compile?
Like, we will need to parameterize over the directives regardless, because in
And
general,
I
Karuta and
think,
Sakura will have different ones.
yeah, but I think that leads up to another conclusion. We shouldn't accept compile clause as an argument. We should accept the inner parts and make clause a part of the functor actually. Like, you're gonna tell us what you're gonna do with these four cases, but we're gonna do these regardless. What do you say? Like, think about it. We have four cases to take care of. Each one of these bodies should be the responsibility of you giving us what to do. Isn't that the case?
It is. Maybe you
Okay.
should accept a compile clause that takes that expects an extra argument, which is how to initialize a nested compiler.
That's not enough. Because, for example, the behavior for queries, well, actually that is enough, right? Because in your we pass what you said to here, and then we are done.
Yeah, because like we need to take the compile clause as an argument of the functor, right? Because we need to be able to say, hey, this compiler takes Karuta's compile clause because it's for Karuta, and this other one takes the ones for Sakura. But compile clause itself needs to know how to make a nested compiler, right? So, but because the signature can't tell you up front which language it is, um, it needs to be able to give compile clause access to initialize nested, basically. So I think compile clause needs an extra parameter.
That sounds a little bit messy, in my opinion, but I don't have a better idea because initialize like it's so weird that we're gonna pass such a like, but I don't have another a better idea. So it's so we are making an argument for the compile clause something that is dedicated to the directives. It's not gonna be used by anybody else. So that feels a little bit like there's a missing piece.
How do you know? How do you know that in like 2050 or something we won't have first
Another
class
thing.
modules?
How do you know?
Because
Okay.
then multi declarations may need to be able to initialize a nested compiler because it may construct a module inside of the body of a predicate or whatever.
Okay, let's actually make that type. So initialize nested. And the type of that is the type of this. So persist t module lookup as with type t equals t option string and returns a t. Okay, then we put that here like that, and we're gonna say that you need the capability. Your compile clause needs to also allow initialize nested. Then in here, this means that this should be at the bottom. And in here, interesting. Okay, so Marinho, do you think those are the only two things we need to expose out of the compiler functor? And again, the main idea is that we're going to be actually sending to everybody else the output of initialize. Is that your plan? And this should be a compiler config.
Hmm. Yeah, because the compiler signature tells you I'm giving you a way to initialize a compiler, and I'm also giving you a way to use a compiler um, to compile stuff,
To
right?
compile clauses, yeah.
Yeah, I don't think we need anything else in the compiler.
Man, that's such a good use of functors, isn't it? Because we are kind of saying that we have an overall structure of what a compiler looks like, but we allow you to pass some custom functionality, which is the lookup capabilities and how to compile a clause, and that's going to be enough for us to do everything else. This is so cool. Like again, seems like a good use case of functors. But like I said, what a day. We are making our compiler a functor. But this means that the executor is now wrong, right? Because it kind of needs to instantiate a functor per file, isn't it?
Yeah.
Okay, that means that this is fundamentally fucked. Let's actually see what Dune tells me. Yeah, it is telling me that. It is in fact telling me that. Okay, I know we know. Well, let's start from executor. So how what do we do essentially? It's in here, isn't it? We need that we have to instantiate the functor in compile one, which by the way It should be this. It should be this.
Yeah, we need to look at the extension and then instantiate a compiler for either Karuta or Sakura.
Yeah, we already have this code, so let's go there. Um, Sakura equals. There we go. So it's essentially kind of like this, which I'm gonna make a function out of this thing. Hey, wait, do we need a Sakura boolean now? I don't
I
think
don't
we
think
do.
so.
Yeah, I don't think we do. You see, we are making a compiler of functor and getting rid of booleans. Marinho is so happy. So we're gonna go here. Then we're gonna do this, and file path. Then we're gonna have to instantiate a compiler, which is gonna be compiler dot types dot make, and now we have to pass a module to this thing. So module. How do I make it? Can I make an anonymous module? Is this a thing?
You can, it's just called a struct.
Yeah, but do I just do struct and?
No, you have to do module struct and because actually you're calling types make, which is a functor, right?
Yeah, this is a functor.
Yeah, you need to put module around the functor call actually.
Like this.
Yeah, and you don't need the module before the struct because this is already.
Yeah, but we're gonna make this
And you need to
externally.
do let module compiler. Actually, yeah, let module compiler is better than putting the module on the right because you need to. You're gonna call stuff from there, right? You're gonna call initialize and you're gonna call step. So
Wait, so you're saying to do this, sort of?
I'm pretty sure compiler needs to be uppercase. Actually,
Here?
it does it. I'm not sure.
Let's discover that in a moment. So what is my contract? I need to provide these two things, right? That's my
Yeah.
contract. So I need to put those things in here. So compile clause is actually gonna be, well, this means that I can now finally rename this. And now I don't need this shit, but I do need to put an extra argument here, which is gonna be compiler types, like so. We have that. Yeah. And what we're gonna do is pass that to this. Actually, I'm not gonna do that, do I? I will. Okay, we have already 5 arguments, which is kind of bad, but I'm gonna put it at the end, like that. Which means that compile, oh, it means that this is wrong. Types that, and it means that immediately before that, we're gonna receive initialize nested, which has that type. There we go. And wherever we are calling initialize from parent, we need to pass that. So initialize nested from parent. Let me actually grab that. From parent. There we go. Pass that. And then here initialize nested. That should be enough. It should be enough. Then now we specify how to compile a Karuta clause, and I need to do the same with Sakura, but Sakura is also a folder, a directory, which means that I cannot just do that. I'm gonna rename this database, and then I can use Sakura here. I don't need step, and in fact, well, I do need the other shit, so let's grab it. Let's grab this. Let's pass that around and initialize nested. And in directive, we're gonna receive something and just return the compiler, because I don't really care.
Hey, I agree with you, Lemons. This is getting cursed.
What?
I have things like okay error and then another state inside, or okay none, okay some.
Yeah,
Like
that
that's just
is, you are introducing states that don't have semantics.
well, they do. It's for the recursion in those cases, but it is very trashy.
Yeah, it seems to be very bad. What do I have to expose in here? Those.
They have some. Let me correct. They have semantics, but not a face value. So you need to actually guess what each one of them do. Let me
Yeah,
change that.
you should make an ADT instead. There. I believe that should be the minimum amount of work for those two. Whew. Then let compile clause. So what's this gonna be? It's gonna be Karuta, right? So actually, okay, Marinho, do I put the if inside the struct or outside of the struct?
It should be outside, no?
Okay. If this.
Okay, here's a basic rule of thumb that is good to follow. If you should try to push your ifs outside as far as they can go, and you should try to push your for loops and your reduces and whatnot down lower.
Yeah, I do understand the principle. So if let's do this case first. So this is gonna be Karuta compile clause. Yeah, and the module should be equals to compiler lookup. That's it. And here, this should be Sakura compile clause. And this should, for now, is going to be the same because we don't have we don't have it. There we go. So something like that, right, Marinho?
Yeah.
So something along those lines. And then if you have a module, we can just initialize a module, right?
Yeah, it should be something like that, basically.
I think mod is already a thing. I have very little faith this is gonna work, but let's see what this expects. This expects a compiler, which means that I don't need this bullshit. Wait, I do need it because the module gives me the step, so I need to pass the step further. I need to pass the step further, which means that this should be an argument. So module step. and the signature of step lives here, val step. So let's grab that. Then we have a step function that does this, and instead of doing all of this bullshit, we just do that. And we can get rid of this. That's my understanding at least. Yeah. And what's the problem here? The value compiler has type this, but is expected to have type t. Oh, of course, it's because these things, they need to know where t comes from. There.
I'm pretty sure it comes from Eastern Asia.
What?
Tea comes from Eastern Asia, no?
No, that's terrible. Okay, that was a terrible joke. Okay, I will
It's
check
logic.
it out, your link later, Ace. Thank you for the link. Okay, wait, some modules don't have an implementation, so something is very fucked. Why is it saying that the Dune file is fucked? Is it because I have a module named Karuta now? Is that the problem?
Hmm.
You need to add the following field to this stanza.
Compile.
Modules without implementation. Wait, somebody's referencing compile module. That's the problem. That's not what I said to grep, but okay.
You probably need to escape the
Ah,
dot.
I know.
'Cause
It's because there's a compile.mli, but you renamed the compile module to Karuta.
Ah, well, what is this? Oh, fuck that. Thank you, Marinho, and thank you, Ace, as well. Okay, there we go. So, let's fix the one at the bottom first. So this can go away. Uh, this can go away, which means that this can also go away. Which means that this can also go away. Oh, okay. Those are a bunch of unused, which we don't particularly care. There we go. So syntax here, line 43. So I don't think this is how you do it, Marin. I don't think this is how you do it. So how do you do an anonymous struct? That's the question. Anonymous struct.
Ah, you have to put the keyword module in front of the both of them actually. Both of this.
This? Are you sure?
it probably needs to be parenthesized too.
Ah, that would figure.
This?
But struct and end are already parentheses, no?
Maybe not. Yeah, maybe. Yeah. I'm very confused by OCaml's parsing precedent
Man,
sometimes.
according to AI, you can only make anonymous records inside of a parenthesis of a make, which is just stupid. Which, by the way, I'm not calling it, right? This is just also retarded, so let me fix that.
Yeah, you need to call.
Temp module, and then in
Yeah, you do
here
need
we
to call
have
make.
module, where we're gonna call compiler types make, and I'm gonna pass temp module to it. So something like that. But how do I make How do we make a module like this? I'm starting to think that's the way
I
we do
put a
this.
link on the chat, Lemos. Take a look at it real quick.
First class modules. Yeah, it is taking a while, but it is opening. Okay, where's my example?
It's in basic example.
Okay, so I don't use a let, is that what you're saying? Oh no, I do put a module here, that's what you're saying, yes. This needs to be capitalized. Let's call it C. And then module printer. Val printer. Yeah, none of these cases are exactly my case. So that's cool. That's actually cool. We don't need this. I'm not sure that's the way, Marinho, actually. Yeah, it
Yeah,
is not
don't.
doing it, actually.
No, it is. You just need to do let C equals blah blah blah. Put the module. But you
Aha.
need to.
Aha, no. There is a practical example, multiple implementations there that is telling me to do this. That's progress. But it still needs parentheses, which is kind of bad. But I don't understand why the if is a problem.
You need to tell the signature, I think.
Ah, yeah, I think you're right. I need to tell the signature, which in
Um,
this case is gonna
try
be
putting the signature on the C instead of putting it on the structs. I'm not sure if that
compiler
works, but
types uh,
config.
compiler config.
Compiler, you're missing an R.
Okay.
Hmm.
And it's still not liking the if. It's pretty much not liking the if at all.
You probably want to take a look at the runtime selection example. So it's right
Runtime,
after, yeah, it's right after the multiple
runtime selection,
implementations.
yes. Oh, but again, it is skipping the hard part of making the struct. It's skipping the hard part of making a struct.
How do I fix this code, Lemos? Tell me.
No, this needs to inform that it is a module. I don't think we can use ifs in this case.
We should be able to. It's just we're
No, you
not getting
can.
the syntax right.
No, you can because in get database, the runtime selection example, get databases using a match.
No, but it's using a mesh without instantiating a module.
No, it is instantiating a module because this is a continuation of the previous example.
Wait, what? Postgres connect. Which line is it is instantiating a module? Sorry?
It's in the previous section. Like
Previous
those
section.
functions actually instantiate modules.
Oh, you guys are right. Okay, but then what the fuck is going on?
I think you need to put the signature after each struct
Okay,
instead
so
of putting it on the C.
that's a little silly, but you're saying to do this.
Uh,
That doesn't seem to be happier at all.
and then I think you also need to put a val around the if.
A vow? You mean? Uh, here? It can't be there, right? It can't be there.
I mean, you could get rid of the module in front of the C as well, I think.
I don't think you can.
And you need to make the C lowercase in that case, I think.
I also don't think
Hmm.
you can.
Okay, that doesn't work. Hmm.
There's something very stupid going on, and I'm pretty sure I'm gonna be pissed when we discover what it is.
Hmm.
Oh, the val stuff is because this is happening in a REPL. For whatever reason. Yeah, but what A said is true. It is doing a match and then immediately doing something else. Do I need to make this a function? Is this what this wants? There's no way, right?
Hmm.
Fuck me. Okay, let's actually do
I'm
that.
just using enumerations out of batteries, by the way.
We're not using it now.
I think we are using it in one place, but I don't remember where.
We are using it as an intermediary state to convert sets. That's it.
Mm-hmm.
Uh,
Because I'm using the finger trees and bat lists, and they're very useful actually.
yeah, they are awesome. We are using sets, we're using finger trees.
The only problem is remembering to use that instead of lists everywhere.
Oh, you can just do it a bet open, a bet list open in the beginning, and then you can use the same things everywhere.
Oh wait, it names the same
Yeah, yeah,
way? And
it
does
does,
he
it does.
override the
Yes,
constructors?
yes.
So it overrides the constructor, the value.
Yeah, if you do bet list open and then you start using list functions, it's gonna grab it from letters.
No, but I mean, like, does it override the open close squared brackets? I
Ah,
don't
that
think
I don't
so.
know.
Maybe?
Ah, yeah, no, you don't. You that doesn't work for finger
Okay,
trees.
so I would need to use list empty, I guess.
Uh, I mean, if you just want the syntax, you can always just use a from list wherever you would have a list literal.
Yeah, that makes sense.
OCaml being dumb. Alright, there's also a skill issue on our part for sure. Okay, so let's imagine that you should not that this is not gonna work. Let's imagine that, and then just say that Karuta. Now this should be Sakura actually. So Sakura unit else Karuta. That's not what I wanted. Why is this broken now? That's the question. Yeah. Okay, so it's not like that.
Yeah, I think I fixed this file. It's already much
Wait,
better.
I think it worked. Wait,
Uh,
it's not complaining about the executed anymore, is it? Am I tripping? Blah 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 blah.
maybe.
Let me fix this unused bullshit first. There, there. Actually, that doesn't work like that because this is not a. This is the name of a field. Uh, fuck that. Fuck that.
Make continuations on the string instead of.
That.
No, I'll keep
That.
this.
Oh, actually, this one should stay. Okay, what else are you complaining about? Okay, so inside directive, oh, this function is recursive. Compile. There you go. So initialize nested. Unused rec flag. Ah, here. This should not be. Oops. Karuta. Unbound value step. That's a problem. Ah, that's a problem, Marinho. We need another argument in here. Ugh. Okay.
So we do.
So step compiler types. I'm starting to think we should have a record for these two things. There
Can't
are
you just
two
receive the
these.
module as an argument?
No, but then if that happens, then actually
Because
does
the
that
module,
work?
because the signature already tells us, okay, this module has a step and an initialize nested. Can't you just like pass the module to compile clause?
Um, we should be able to. So let's grab that, put it in here, and instead of receiving that, you're gonna receive.
Ah, but you don't receive initialize, you receive initialize nested. That's the, I see.
No, but that works, right? Ah, no, that doesn't work because then we would have to export initialize nested to receive that as a thing, right?
Yeah, we should probably
Make a type.
just pass it as a record, I guess.
Yeah, we should make a record for those things. So let's actually make that. Well, in that case, I'm gonna swap this back because to me
Do this
this makes
function
more
already.
sense. And then in here we're gonna have a type, I don't know, runner. And then for that, you need this, and you need this. That's not how that works. Um,
Semicolon.
and then in here actually, you should receive. You should receive that. Then in here, you're gonna receive bye to all of those things. There we go. Which means that this should just work out of the box, and I'm gonna copy this and put it into the Sakura one as well. Or in this case, it's just easier to just do this. And then here, these things should not receive unit anymore. They should receive a module. Wait. We can't do that, Marinho. You see why?
Why?
Because to instantiate. Wait. Am I saying bullshit? Yes, I am saying bullshit. Because it's not here that we need to do this thing. It's here. Yeah, it's here. So compile clause, it receives. Oh, we actually need to change the functor as well, because in the step function, yeah, this is not gonna fly anymore. We need to create a record for this, which should be just be ourselves. So there. Yes. Okay, is that better? Initialize nested in compiler directive. What's the complaint? This module Sakura is an alias for lib Sakura, which is the current compilation unit. So it's complaining about line 43. Wait, unused? Oh, rec flag. And probably the same applies to this. Okay, now we have only a single error. Whew, okay, so it's complaining that initialized from parent blah blah blah. So let's go to line 43. What's your problem? This takes... Wait, this is written in a very... Ah! No, it is correct. It should be the second argument. And it is the second argument. So what's the problem? Receives a string, which is this, receives that.
You need to pass a lookup now, don't you?
Need to pass a lookup. What? What do you mean? What do you mean by that? The lookup should already be there. Yeah, the lookup should already be there, because this is being provided by the functor itself. Remember, this is here, this implementation, and you shouldn't know how to write one of these.
No. But the point is, that function now takes an extra argument, right?
That function now. Ah, you're right. It takes an argument here. Ah, fuck me. Okay, but then we are leaking how the lookup is done, aren't we?
Hmm.
So that means
Maybe initialize from parent shouldn't take a lookup as an
exactly.
argument,
That's
actually.
what I was about to say. We need to swap yeah, we need to swap. This should be the second argument, and then we partially apply the lookup. That's how that should work. So here we need to partially apply this shit. Actually, even better, this should not be an argument at all for this guy, because this is what everybody is expecting. This is the interface. But in here, we should actually pass our lookup. But to do that, you need to pass this as that. And you probably need that. Syntax error. That's not how you do that, apparently. And I wonder why. I actually do wonder why. It's because this is in the opposite thing. So that, which means that these are also swapped. What is the problem?
Can't you just get rid of the extra argument? Because initialize nested is being defined here, right?
Yes.
So it closes over the config, right?
Oh, okay. We can do that, what you said. We can just do equal config lookup module. That's what you mean, right?
Yeah.
And then we can just get this nuked. And the same applies here. Helps for absolutely nothing. This error message. I'm going to finish the recording because you already have 2 hours there. But we're going to continue to make this work.